Hello class, Mr. Husted here, and today is the day we have all been waiting for. We are jumping right into proofs today. We're going to start off with some easy things. We're going to be talking strictly about proofs, and we're going to be using algebra today. So everything's going to be number-based, math-related, but we are going to start working through proofs and how those are supposed to look. So let's jump right in. Okay, lots of key concepts today. First thing is what's known as the algebraic properties of equality. The short of it is basically we are allowed to add, subtract, multiply, or divide by any number on both sides of the equal sign. Notice that we have equal signs here. Okay, and so if we can add or subtract or multiply or divide by the same number on both sides, and our equation is then still true. So those are just properties that we use to solve equations every day, but now we have words to them. So if we add the same number to both sides, it's the addition property. If we divide, it's the division property. Simple as that. Okay, all right, so let's take a look here at example number 1. Okay, so what they want us to do is they want us to solve 2x plus 5 equals 20 minus 3x, and they want us to give a reason for each step. Okay, so we're just going to solve this like normal. Okay, so our first step that we would do is we always want to get our x's onto one side, so we're going to add 3x on both sides, and I can't do anything else until I give a reason for this. And we'll just put an arrow off to the side here, and since we added the same thing to both sides, that is the addition property of equality, which we can shorten it to the addition of equality. Notice the equal sign because it is the addition property of equality. Our next step is to combine our like terms, so those will cancel out here. We'll get 5x plus 5 equals 20. Again, we need a reason for that, and there is no reason for this other than when we combine like terms, it's just known as simplifying. So we just simplified our problem there. Next, we want to get everything away from the x, so we're going to subtract 5 on both sides. That is simply going to be the subtraction property of equality. And again, right now we're just using equality because we are dealing with an equation. There are inequalities, there's all kinds of other stuff that we'll use too, but today is just equality. Simplify it down, so 5x equals 15. That is just simplify. And then finally, to get x by itself, we'll divide by 5 on both sides. That's going to be the division property of equality. And imagine that, I've run out of room, but we will get x. You can almost see that. Let's try to make that just a little bit bigger. Then we'll get x equal to 3, and we did that by simplifying. Okay, so that's basically what a proof is. We gave a reason for each step as we walked through it. Again, this is everything you've done before. We are just now putting reasons to it. So make sure that every time you do something, you know the reasoning behind it or the property behind it and why it works the way it does. Okay, another key concept, something that we use every day, or almost every day, is the distributive property. So when you have something like this, just know that that A gets distributed to the B, and the A also gets distributed to the C. So a lot of times you'll see people draw arrows to show the distribution. Okay, so let's throw that into a problem here, and again, give a reason for each step. So the first thing we have to do here is we are going to have to take -4 and multiply it or distribute it to everything inside the equation. So we will get -44x minus 8 equals 80, and that is the distributive property. And you can shorthand a little bit, just make sure that there's enough of it that we can understand what actually is going on. Okay, and then like we've done before, x's are all on one side, so we want to get everything away from x, so we're going to add 8 on both sides. That is going to be the addition property of equality. we'll get negative 44x equal to 88. Whoops, 88, not 80. That's going to be our simplify. And then finally we will divide by negative 44 on both sides. Negative 44 on both sides, it's going to be the division property of equality. And then finally x will be equal to negative 2. Again, we just simplified. So again, nothing that we haven't done before. Solving equations is, we've done it before, we're going to continue to do it, but now there has to be some type of reasoning that goes along with each and every problem. Okay, so make sure that you take a look back at this entire page. Okay, look at the properties that we have, because we're going to be adding more to them. So again, as I've suggested before, maybe do a little highlight around, a little star, a little circle, something, so that draws attention for when we start to do these larger proofs. Okay? At the back, because this is when it starts to get real fun, as we start throwing in a lot more stuff. Okay? So we have the reflexive property of equality. And reflexive property of equality just means that I can look in the mirror and hopefully the person I see in the mirror is the same person. That's me. It's my reflection. So like they have A is equal to A, or a segment length is equal to the same segment length, or the angle measure is equal to the same angle measure. That's what reflexive property means. Symmetric property of equality just means it's kind of like the... and we'll put it up here for you. It's very similar to what we call the commutative. If I could write here. Oh man, rough morning. Commutative. Basically means if A equals B, then B equals A. Okay, so like again, segment length AB equals CD, then CD equals AB. And then finally, the transitive property of equality, which we have talked about many times. If A equals B and B equals C, we take out that middleman and A equals C. Trying to think back to what that property was that we learned just the other day. That was very similar to the transitive property of equality, where you could, I believe it was the law of syllogism, where you could just take out the part that they had in common, and so then you had your if from one statement and the then from another, and the middleman was gone. So that's very similar to the transitive property of equality. Okay? So we're going to take all of that, everything we've done so far, and we're going to put that into a proof. This is really your first full-length proof. So make sure that you pay close attention, make sure you understand what we're going to put down here, as it can be a little intense. Okay, so here we go. In the diagram, AB is equal to CD. We want to show that AC is equal to BD. Okay, so first thing we always start a proof out with every time is what is given to us. So they tell us that AB is equal to CD. So AB is equal to CD. Okay, and that is nothing more than given to us. That is a given statement. We don't have to prove it. It's already there for us. Okay, so what we are trying to do is we are trying to take AB and CD and break that into AC is equal to BD. So from here, we're just going to start kind of breaking this down and writing anything down that we are able to figure out here. So let's start with, we're trying to find AC here, so put a little highlight over AC. We know that AC is this segment right here. It is equal to AB plus BC. And the reason we know that is because of the segment addition postulate, which we learned that back, I believe, in chapter 1, that a segment is made up of two smaller segments added together. So we know that AC is equal to AB plus BC. Okay, we want to try and figure out how we can draw BD into this problem. So we will say BD is equal to BC plus CD. Again, That's segment addition. Okay? So this is where it gets a little tricky. We're going to go back to our original statement, and I'm going to do the best I can to make sure that each time you have each of these statements already kind of laid out for you, and you just have to figure out the postulates, theorems that go with it. But for now, I want to look here and see that AC is equal to AB plus BC, and BD is equal to BC plus CD. Notice what these two have in common. They both have BC in common. So, because they both have that in common, I can add BC to both sides. Okay, and that's just what we ended up with. That is just the addition property of equality. Okay, so now we have, let's find my lightsaber here. So we said AB plus BC is equal to CD plus BC. Up here we said that AB plus BC is AC, and we also said that CD plus BC is BD. So because we've said that, and I know I'm telling you right now it's probably going to create a lot of confusion, this is what's known as the substitution property of equality, which just means that if I have something equal to something else, I can substitute it back and forth as long as the statements are true. And there we go. We wanted to prove that AC is equal to BD, and we just did that. Now I know that's going to create a lot of confusion. I know you're going to have lots of questions. So what I encourage you to do is go back, rewatch the video, at least this section right here. Make sure that you have gone through, that you have highlighted all of our key terms and everything, key concepts, because those are what's going to be able to help you as we work through these problems. Okay, so bring all your questions with you to class, and we will see you then.